Okay, today we're going to talk about solving absolute value equations. Okay, solving absolute value equations. So as a reminder, what does it mean to find the absolute value of a number? Okay. Absolute value of a number is simply the distance from 0 on a number line. Okay, distance from 0 on a number line. Okay, so it doesn't matter if I'm going a units to the right or going a units to the left. Absolute value of positive a would still just be the value of a. Absolute value of negative a, even though I'm going left, I don't care about the direction. All I care is about the distance. So the distance is still a. Okay, so absolute value, since it's distance, is always going to create a positive value. Okay. So today we're going to focus on solving absolute value equations. Okay, so what does that look like? Well, if I want to solve the equation absolute value, distance from 0 of x minus 3 equals 9. Well, with absolute value equations, we have two options. Okay, I could have my distance from 0, x minus 3, could be equaling 9 units to the right, or I could have my absolute value distance from 0 equaling a negative 9, Okay, so when you have absolute value equations, you need to split into two equations. Okay, rewrite as two equations. Why do we need to rewrite? We need to rewrite because, again, I could be going to the right that direction, or I could be going to the left. Okay, so everything inside, once it's isolated, everything inside equals positive 9, or it could equal negative 9. So now we're just going to solve for x. So we can add 3 to both sides. So 9 plus 3 is 12. Here, if we add negative 9 plus 3 is a negative 6. And before we box our answers, we should always check. So how do we check? We check by plugging into the original equation, okay? So my original equation is absolute value x minus 3. Our first x value is 12. Absolute 12 minus 3 is 9. Absolute value of 9 is 9. 9 equals 9. Check, I can box 12. So let's do the same thing with 6. So absolute value, this time we're plugging in, negative 6 minus 3 equals positive 9. Negative 6 minus 3 is absolute value of negative 9. Absolute value of negative 9, distance from 0 to get to negative 9 is still positive 9 equals 9. Check, I can box my answer. So two values for x I can plug in to satisfy that equation, x equals 12 or x equals negative 6. So let's try another one. What if this time we have solve negative 5 plus 3 times absolute value for w minus 1 equals 10. There you go. Okay, first step is to isolate the absolute value. So we need to isolate the absolute value, okay? So how do we isolate the absolute value? That means that we need to get the absolute value all by itself on one side. So is currently the absolute value all by itself? No, it is not, because we have these numbers on the outside. So first, let's start with what's furthest away. The furthest away is the minus 5, okay, minus 5. And notice this is minus 5 plus, okay? So this is really subtracting 5. What is the opposite of subtracting 5? Opposite of subtracting 5 is adding 5. So use your inverse operations. Whatever you do to one side, you have to do to the other. So if we add 5 to both sides, we're still left with 3. Absolute value for w minus 1 equals 15. but it's still not isolated because we have 3 times the absolute value. Well, what is the opposite of multiplying times 3? That would be dividing by 3. So absolute value for W minus 1 is going to equal 15 divided by 3 is 5. Okay, so first step, isolate. Get the absolute value on one side all by itself, move everything over using inverse operations to the other side. Okay, now that we have absolute value isolated, we can rewrite into 2 equations. So rewrite as 2 equations. Okay, so what does that mean? That means everything inside 4W minus 1 could equal positive 5, or everything inside 4W minus 1 could equal negative 5. So everything inside does not mean change plus or minus on the left side. It's only on the right side, positive, negative. Okay, so now we're just going to solve for W. So add 1 to both sides on both options. So 4W equals 5 plus 1 is 6. 4W equals negative 5 plus 1 is negative 4. And divide by 4, because 4 times W, opposite of that would be dividing by 4. So 6 divided by 4, it doesn't go in evenly, but that's okay. We can keep fractions now that, we can keep fractions as long as they are simplified, okay? So we can divide both of those by 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. So what can we do on the right side? Negative 4 divided by 4 is a negative 1. Okay, before we box our answer, we should always check, okay? And I'm going to show you how you can check your answers graphically, or if you're having trouble finding answers, how we could find these answers graphically, okay? What you can use is Desmos graphing calculator. So let's pull up a Desmos graphing calculator. So again, I would bookmark this on your computer or Chromebook, as we will be utilizing a Desmos quite a bit. Okay, and you're going to hit the graphing calculator. And we're going to put in the original problem. Okay, my original problem was negative 5 plus 3 absolute values. So we're going to come down here to the little left side of where it shows keyboard. And here we have absolute value. I have 4. Instead of W, we're going to put X minus 1. Close absolute value. So we're going to put the left side. So notice negative 5 plus 3 absolute value for X minus 1 is on the left side. And we're going to put what's on the right side on the second equation. So we're going to put 10. Actually do y equal, and y equal. Okay, so again, when I'm graphing this on Desmos, okay, the left side of the equation goes on one line, equals y. The right side of the equation, 10, goes on y equal, goes on the second line, okay? And what we need to do here is we are looking to find the point of intersection. So notice I only see one graph here. I only see the first graph. And from our first chapters, we should know that, well, if I have absolute value equation, that means that I'm going to have a V shape, which I do. But notice that my second equation, y equals 10, 10 is not currently showing on the graph. So I need to zoom out, okay? So I'm going to zoom out so I can see my graph. And you can kind of move it if needed. So notice here are my 2 intersection points, okay? So the solution to an absolute value is what X value is true, which makes the left side equal the right side. Left side equaling the right side means that it's going to be the point of intersection, okay, or points. Reminder that with absolute value, we often have 2 different values that will work for, because again, distance from 0 could be going right or left. So let's look at the point of intersection here. And if I click on this point of intersection, notice I get the exact point here of negative 1, 10. And notice, what is the X value? The X value is negative 1. Is that not what we got as one of our X values? Y equal. W equal -1? Yes. Why? Because the Y value is 10 when X is -1. So yes, -1 checks. And let's go over to the right-hand side. You can either click on it or you could even right arrow. You can kind of follow it down. Notice this is showing you all the points on the graph. And again, we're looking for point of intersection, point of intersection. And notice this second point of intersection would be at 1.5, 10. Again, when Y equals 10, what's the X value? Well, X value, again, in our equation or in our problem was going to be W. And 3/2 is the same as 1.5. So that verifies our two answers. So if we go back to our work screen, again, to show you visually, why is this the answer? Yes, these both check. But why does it check? Again, when you graph it, you will have your V. You're going to have a line up here at 10. So this will be 5. This will be 10. It's going to touch the graph at -1, or the two graphs are going to intersect at -1 and 3/2, or 1.5. So you're going to have a point here, and you're going to have a point here. And your V shape goes something like this, way along down there. And the right-hand side goes like this, okay? So again, why is it the intersection point? It's the point of intersection, point of intersection. So if you're having problems solving these algebraically, maybe you can graph it, desmos.com. Again, bookmark that on your Chromebook or computer, and you're finding the point of intersection, left side to right side. Okay, so let's try one more and let's see what happens. What if we want to solve absolute value 3x plus 2 equals 4x plus 5? 3x plus 2 equals 4x plus 5. Well, again, first step always is to isolate a radical. Well, I already have my radical, or not my radical, my absolute value. I already have my absolute value isolated on the left-hand side. So that step is done. So next we need to rewrite as two equations. Rewrite as two equations. So if we rewrite as two equations, we have everything inside, 3x plus 2 would equal positive 4x plus 5. Or we're going to have everything inside, 3x plus 2 equal negative parenthesis 4x plus 5. So let's start on the left-hand side. I'm not sure if you can see that very clearly. That share screen is in a very wonky spot, isn't it? Okay, so let's just solve for x on both sides. So I can subtract 2. And I can actually do that across, actually, we're going to wait to do the right. Let's just do the left side for now. We're going to subtract 2 from both sides. So 3x equals 4x, 5 minus 2 is 3. We can then get our x's on the same side, so we can subtract 4x. Negative x equals 3. And to get a positive x, we need to divide by -1, or just change your signs. So let's do the same on the right-hand side. Notice before, I actually need to back up on this. Before we subtract 2, notice what's different on this one. Notice on the right-hand side, I don't just have one number. I have a binomial, okay? I have a variable and a constant, okay? So when I take the negative of the right-hand side, I'm going to have to distribute that negative. I'm going to have to distribute that negative. So I'm going to end up with 3x plus 2 equals negative 4x minus 5. Now I can get my x's on the same side. I want to keep things positive, so I'm going to move the 4x over, add it, or to keep things positive. So we have 4x plus 3x is 7x plus 2 equals negative 5, because those are going to cancel. And to isolate the x, we can subtract 2 from both sides. Negative 5 minus 2 is negative 7. And 7 times x, inverse operation is to divide by 7. So x equals a negative 1. So let's check this. And again, you can check it by either plugging it into the equation, or we can graph. So let's go to Desmos, because I think visually graphing helps us in a variety of ways. So go back to a Desmos graphing calculator. And again, clear out the current equations you have. Okay, so we're going to put the left-hand side, which is absolute value, 3x plus 2. And the right-hand side is going to be 4x plus 5. So let's look here. Notice our left equation is absolute value, so we have a V shape. That is our red graph. And notice 4x plus 5, the right-hand side, is a line. So let's look at the graph, okay? Again, we are looking for the points of intersection, And where do we actually have the point of intersection? We have the point of intersection right here at this point right here. So what is this point of intersection right here? If you come over here on the graph, where is that exact point of intersection? It's going to be at, let's see if we find it exactly. You can click on the graph and you can go down with your arrow if needed to, right here at negative 1, 1. Okay, so the point of intersection is at negative 1. Now, do we see any other intersection? Notice as I increase my x value on this V, my linear line actually has a steeper slope. So they're actually never going to intersect. They only intersect once. Now, why is that? Well, this time, absolute value equations sometimes have what's called extraneous solutions. So let's go back to our algebra work and let's look at algebraically why we can only accept a negative 1 as our solution. So let's try checking. Let's check our answers algebraically to see if negative 3 is going to work. So if we check, again, we're going back to our original. Absolute value 3 times, again, we're plugging in negative 3 plus 2. And that needs to equal 4 times negative 3 plus 5. Well, 3 times negative 3 is a negative 9. Negative 9 plus 2 is a negative 7. 4 times negative 3 is a negative 12, plus 5 is 7. Well, absolute value of negative 7 is positive 7. Negative 12 plus 5 is negative 7. Uh-oh, does positive 7 equal negative 7? No, it does not, okay? So this is what we call an extraneous solution. It is an extra solution that does not exist. How do we know it doesn't exist? When we graphed it, notice when we graphed it, it did not intersect. These two equations, left side and right side equations, did not intersect at x equals negative 3. That is why it is an extraneous. Now let's double check just to be sure a negative 1. So if we check negative 1, we get absolute value 3 times, again, negative 1 plus 2 equals 4 times negative 1 plus 5. 3 times -1 is -3 plus 2. So -3 plus 2 is -1. 4 times -1 is -4. Plus 5, absolute value of -1 is +1. -4 plus 5 is +1. Yes, this one checks. Note, remember the graph did intersect. The two graphs did intersect at x equals -1. Okay, so again, here we have what's called an extraneous solution. Extraneous solution. Let's define that for you. An extraneous solution think of it as an extra solution. Okay, it is an extra solution. It is an extra solution. It's an extra solution that does not work when checked. An extra solution that when checked an extra solution that when checked, when you plug in that x value, left side does not equal right side. That when checked does not work in the equation. And this is why it is so very important to check. And you will find that most often the extraneous solutions are going to occur when you have a binomial on that right-hand side, okay? But you can check either algebraically by plugging in those x values, making sure the left side equals the right side, again, or we could check by graphing. And to show you one last time, again, why this last one only had one answer we could box. Again, you have to reject if it doesn't fit. Remember this, these two equations, they intersected only at the x value of -1, not at 3. Notice it's never going to intersect over here at 3. Okay, so we have to say, we have to say bye-bye. X equals -3, we have to reject it. We have to reject it. It does not make sense in the equation, okay? So when solving absolute value equations, we could have no solution. If the left side never equals the right side, it could be no solution. And think about graphically, there's times that the graph could never intersect, so we could have no solution. You could have one solution, just like we did in this problem, or you could have two solutions, just like we did in the last problem. Okay, so that is solving absolute value equations. Isolate the absolute value. Get the absolute value on one side all by itself, then rewrite using two equations, okay? And if you need to check or if you need to verify by graphing, don't be scared to do that. The left side goes on one line in the graph, right side goes on another line in the